everybody. This is Peter and David. And hey, David, it occurs to me we're going to have a snappy name for this. We seem to be doing a podcast like at least weekly, if not nightly, doing these different tests. So we're gonna have to come up with some kind of name. But say hi to everybody.
Hello.
Good. So we're gonna do a test to compare the scalability of a Lucid-backed cloud. And connecting to 300 clients, as well as doing it kind of a traditional way with a big file server. So what we've done here is spun up a big beefy M4 10x large 10 gigabyte server in Sydney, AWS, in the Sydney region. And we're going to use that first for the Lucid Hub. We're going to run that as a Lucid Hub. And we're going to spin up 300 clients to connect to it, to connect to a Lucid cloud, ingest a gigabyte file, measure how long it took, output some reports, and we're going to collect all that data. Then we're going to turn around, delete all of those, because we have a 300 limit for how many concurrent servers we're able to run right now in Sydney. We keep dimming the lights every time we run this test in the data center there. And then we're going to run the same exact test, only instead of running that big beefy server as a Lucid Hub, we're going to run it as just a traditional file server and have all 300 of those clients connect through share and download the file that they need to with that. So I'm going to let David kind of walk you through the infrastructure, the setup here, and then we're just going to kick off these tests one right after the other and see what happens.
Excellent. Thank you, Peter. So as Peter highlighted, we've got a M410X large, which is a 10 gigabit network connectivity server within AWS. It's running our Lucid Hub, and it's also a file server. So if I navigate to that one now, ends in IP address 83. Navigate to that now. At the moment, I'm logged in on this machine as a hub, as well as I've logged my Lucid client in. I've logged my Lucid client in because we've made a data folder within it a 1 gigabyte data set. Now, when the Lucid client's machines connect to the Lucid cloud, we'll see them populate here. We'll also see them write a directory based on their client private IP address as a subfolder within the root folder of Lucid, populate that with the robocopy report of copying the 1 gigabyte file from the cloud through S3 to their local My Documents folder. And then we'll also capture the Lucid log so that we've got that data captured along the way. Then once we spin up as a file server, I've got a share within C drive Windows. It's been shared as a file share so that all my users can see that. Within that folder, I've also got the same data set with a 1 gigabyte file. So when we spin up our clients that are connecting to an SMB share, they're going to connect to this server, do a local copy off a mapped drive, and also create a subfolder based on their IP address, populate the copy log for the robocopy to give us the results of that transfer. So I'll start in the Lucid folder because we'll spin up the Lucid clients first, and I'll flip back to AWS. I've got two AMIs. Two AMIs is a Lucid client with reports. So we'll launch him first, and we'll choose a C4 extra large high network, configure instance. We'll spin up 300. We'll say review and launch. We'll say launch. We know we've injected the image with a password. and our 300 have launched. So while they spin up, we can see their IP addresses have started to populate in this column for the private IP. These are the subfolders they're going to create as they output their reports. So we'll flip back to the hub hybrid file server, and we'll wait for them to start joining the cloud here through the hub service daemon. And as they copy, we'll see them create a folder to reflect their individual IP addresses into the Lucid cloud.
Yeah, so we're really interested in seeing how this is going to behave once you start flooding it with that many servers going concurrently, and what sort of throughput that we can get on that file copy throughout the entire process. Generally what we'll see, because it takes a while for AWS to spin up each individual server and log into the cloud, towards the two tails, here we go, you can start seeing that go now. Later on, it's going pretty quick. Right towards the end, it slows down a little bit as we think it's AWS spinning those up. But what we kind of notice is that on the two tails of the reports, first, before all 300 are doing their copy, what kind of throughput we're getting, and at the very end, those tend to be a little bit better. But once you get all 300 of them kind of overlapping, or the largest portion of those overlapping, that's what we'd want to see in a more granular fashion, so that we can learn a little bit more from this. And that's why we're putting each individual server output into its own folder, so that we can then ingest that into an Excel file or something, do some graphing and get some interesting data out of that.
So as you can see, we're up to 215 client connections, and we've got 204 items. So the lag is obviously them connecting to the cloud, mounting the drive, and then starting the robocopy. But it all seems to be going according to plan. Inside each of these folders, if I select the time, the oldest time, at 6:08, we'll see we've got our two files. We've got the Lucid log from the client, okay, and we've got the synchronization report. So this one copied and has finished already, 1,500 megabytes per minute and 36 seconds for our 1 gig file. If we scroll down to the next chunk, we have 1583 megabytes and 36 seconds. If we scroll down to another chunk, we have 1275 and 44 seconds. And if we scroll down to another random report, we have 1394 and 41 seconds. Scroll down quite a bit and select this log, and we've got 1151 and 49 seconds. And scroll down further. I'm trying to find the last file to make sure the transfer is copied, 1321. And in fact, I'll go right to the end, Peter, because I would say, no, we haven't finished yet. We have finished there, so maybe we're about to finish now. Yes, we have. So I would say we've finished now at 11:14 and 51 seconds.
So all of those are pretty consistent at 20 to 25 megabytes per second.
Yeah.
That last one really being the slowest one that we saw come in at 18 and a half, but right around the 20 to 25 megabytes per second mark.
Approximately, yes. Yep. Okay, so now that that's finished, I'll flip across to my file server share, and I'll go through and delete these instances. We'll fast forward this, and we'll be back in a second. Excellent. So the only thing we have to do differently here is join the security group of Launch Wizard 6, which is FA845, I believe. So when we go to AMI and spin up the file server client and go to launch, we'll choose the same size, C4 extra large. We'll say configure instant details. The instances are going to be 300. We choose add storage. We say add tags. We choose our security group, and we specify an existing security group, which is going to be Launch Wizard 6 FA845. That's given us our all traffic rule to be able to communicate with the file server over SMB or CIFS. We say review and launch, and we say launch. We know we've got.
So obviously we won't see these logging into the cloud, but instead we can still flip over to the file server, open up Task Manager, and watch the performance.
Exactly. So we'll see the transfer take place with the send, and we'll see the directories being created as they're outputting their results. We'll also see when they've finished and how long approximately it takes them to finish, because we'll see the I/O spike and drop off as the last remaining tail end performs its transfer.
Okay. Now, Dave, on the previous test, we're still on build 945.
That's right.
Is it right?
That's right.
So this is this is the build from about a week ago that we started doing most of this testing on. We wanted to remain consistent. We started to roll in a number of performance enhancements that we're going to see probably out of this next week or so. That's going to have some significant improvements, but those have not been done on this test. This is still that test that we've been using for a week or so.
Exactly. So our clients are connecting. As you can see, we've had a 125, 134 clients connect. You can see them incrementally growing as they populate their own folder for their reports. Our 10 gig client is maxed out, or our 10 gig server is maxed out as the clients start copying. So we've got 200 concurrent copies going right now, and that's just under 9 gigabits we're occupying of the beefy server's throughput.
So with that bandwidth maxed out and still not all 300 machines up, what we expect to see is that there will be some tail off of throughput as additional machines start hitting that, and then maybe towards the end of the tail, as the first machines start dropping out of that, getting a bit of an improvement.
So as we can see, it's on the downwards now. It's going to start leveling out, and then it'll start peaking back up, but I think it's still got a fair bit of time. I'll leave my mouse cursor there so we can see it is at that checkpoint.
Yeah, we'll see how long this actually takes. We may want to fast forward through this bit a little bit as well. But we'll make sure that you can see the clock so that you can see how everything is proceeding. All right, so we can see that the bandwidth has increased to 9, and we know that that's because a few of the first ones have dropped off, which meant that we've gotten allocated additional bandwidth for the other ones, there's less contention within the server. And then it starts to drop off as the numbers of earlier ones begin, they're finishing up. So there's fewer and fewer clients in the system that are still having to copy. So we'll see that drop dramatically down and finish off in a second. On the right-hand side, we've got 301 folders that have all outputted. Most of well, they've at least been created, and they're still outputting the robocopy report. Here it comes down. You want to take a look at one of those folders, Dave?
Exactly. So I'll sort by timestamp. So we know at 6:19 it started. So we know it's elapsed 5 minutes to perform that task. So if we look at the first one, we were going at 300 megabytes a minute, and it took 3 minutes and 6 seconds. We'll move down a chunk, and 299, 3 minutes and 11. Move down another chunk, 266 and 335. Move down a significant chunk to the middle, and 238 and 4 minutes. Move down a further chunk, 253, 345, so it's going back up again. And then I'm just going to scroll to the last couple here, and we've gone 284 and 321, and the second last one is 478 to 159, and the last one, of course, is 456 and 205.
So it's pretty consistently where the Lucid ran about 4x, in some cases 5x faster in terms of the throughput, and was really pretty stable all the way across. Scaling across 300 was no problem at all. Hey, S3 did a great job too. I mean, this is each one of the clients that are actually streaming directly out of the S3 bucket. So that's a pretty good job on Amazon, don't you think, Dave?
Certainly do.
Right on. Thanks, everybody. Have a good one.
Take care.